So in this video we're going to be looking at functions once again, but this time we'll be looking at a more simple example on how to understand in a more easy way what really functions are. And for this, so we're going to be using a real life example. So first of all, the real definition of a function is basically like the relationship between two things using like a sort of tool. So in this example, so right here, let's set it up. So you can imagine here that this blue circle here will be your input, so it's whatever you have at the start. It's your first set, and it will have a certain relationship with the other circle, which we'll call the output, but we can only obtain this output if you pass it through a machine or a tool. And so this red square here will put all of our tools in this example. So first of all, let's have the same input for every single one. Let's start off simple with a blank sheet of paper. So now let's imagine we have 4 tools. Could be anything. So in this example, we'll have a hand, scissors, a gun, and a knife. And so what we're basically going to be doing is having our starting material, which is the blank paper, and passing it through each of these tools, and then we'll see what the outputs is, like what the outputs are. So first of all, let's start off with the hand. So what if you pass the blank paper with a single hand, like this one? What you could do is actually you could crumple, for example, your paper like this. You can just imagine these tools to do like just only basic functions, because of course a hand could rip paper, but let's just use a single hand alone, and all you could basically do with it is just crumple it. So your input is your piece of paper, the machine or tool that you're using right here is a hand, and then you end up having crumpled paper. Let's see the second one. So this one, you still start with your paper, you pass it through scissors. What would you get? You would get just a piece of paper with cuts in it. So we could write that out with arrows like this. So your input paper with your machine, which is the scissors, and then your outcome or output right here is cut up paper. Now for the next one, let's look at what if you pass it through a different machine, like the gun, like this one. So imagine you could shoot the piece of paper. Well, you would end up with a hole in your paper. So you can see that every single machine that I've been using so far, we have a different output. But so let's see finally for the last one. If you use your paper but pass it through a knife, you could imagine that if you put a paper against a table or something, and then you pass a knife through it, you could actually have the same output as the scissors. So in this example, I'm really trying to show you that whatever you put in your as an initial like material, so here we're using the paper, you could have different outcomes depending on what tool you're using. And you can see that some tools you can actually end up with the same output, but however you could never get, for example, like the hand. If you use the hand, you would never be able to get crumpled paper but also ripped paper like this one, or have a hole in it. So each machine actually has its specific function and will have a certain outcome depending on what it is. So let me show you now what happens if we talk more about math with this example. So let's replace a few things. Imagine here we're using functions, so actually what I have been talking to you about using these machines, you can actually replace with functions. And then you can also replace your input and output by numbers, and there you go, you have the same concept as a function. So first of all, let me show you, let's get all of this out of the way first. So now I'll just show you what happens, like what is really the meaning of using a function. Because you might see x and y and just random numbers going around, but what is their real like meaning? So, two more. There we go. So, let's use this simple function at first. So, what does it really mean? There's actually like a significant way of using this. Is that, so you can see that there's the y and the x, and we basically use the x usually as an input. So this is like the x, it actually represents anything. So when you see an x, it's a way of saying any number. And then your output is always the y. And so a function, what it's really doing is it's almost like a tool, and whatever you put in, so whatever different values you put into the x, you'll have a different y value. So let's look at it just on a graph first, so you can see what I mean. There we go. So let's use the y equals x, and now let's try a couple things. Let's try, for instance, what if we replace this x by a number, and we put in 1. So what is the value of y? So now you know what y equals 1. This is a very simple example. So let's plot it. So you can see here, this is the x-axis, and this one, the vertical one, is the y-axis. So right here, we plugged in x equals 1 into the function. And so it would be on this line right here on 1, and we saw that the result is y equals 1. So you move it up right here, and this is the result. Let's move it. It's a little bit large, but that'll do it. So this is the point where your x is equal to 1 when you are using the function y equals x. Let's try to change number. What if, so you have your x here before, let's change it up and have a 2. So this one, once again, you can see if your x is 2, so here on the curve, your y would go up and be here y. So this example is a bit more simple, but after a while you could see, let's try new numbers. So what if it's, let's say -2, your y would be also -2. So -2 is right here. This would be the point on your graph. And so what this means is that the more numbers you use, the clearer it will get, but you will see that there's actually a trend that every single point they end up forming a line. And so you can replace this line, these points, you can just move them out and have a line. And the line right here represents the y equals x. And so this function is basically a way of showing the relationship between your input, which was the x, and your output, the y. And so that now whatever number you use, you'll always be able to tell which, whatever value of x you put in, you'll know what the y value is. Let's try with a different function, because of course they're not always the same. Let's try this one actually. So let's see this one. It's y equals x plus 1. So this one's a little bit different, because you'll see that for whatever value you put in x, it will be changed every single time by 1. And so you can see already that compared to this example here where y equals x, y is always going to be equal to the same x, whereas on this one, there's always going to be a difference of 1. So let's see how it works on the graph. So let's copy it. There we go. So what if, using the same example as before, let's try to change the x and turn it into a 1. So your input right now is 1. So let's see what the output is. We'll have to solve for it, and so we'll have to find a new value for y. So if you do 1 plus 1, it's going to be equal to 2. So now you know that when you use x equals 1, using the function of y equals to x plus 1, you'll have y equals 2. And so right here, your x was 1, but this time your y is equal to 2. Let's try for another value. So, there we go. If we use x equals 2, like this, and you add them up, 2 plus 1 will get us to 3. So now we see that if your x value, so the input is 2, your y value, so the output will be 3. And once again, so 2, 3 right here. And if you keep going, once again, you'll start seeing that there is a trend. The more numbers you use, that's a bit big. And once again, you'll get a straight line. Well, this one happens to be straight right here. And this is the relationship. So this line shows us the relationship between the y and the x. So this is what the function is going to do. So let's try to use our example again that we used with the paper and see how it works out with numbers. So we'll put in our output, input, and this time it's not a tool, but it's a function. So we can put our tool or function square right here, our inputs, and our output. So let's make all this smaller so I can show you on the graph as well. Like this. It's just going to be the same diagram but in smaller. Alright, so let's try to have a couple of functions. So we'll have this one first. This one is y equals x squared. We'll also have y equals negative x, y equals 5 minus x, and finally, the one we used earlier, y equals x plus 1. So remember how before we had a piece of paper? We always had the same input. So for this one, we'll also try to do that. We'll have the same input for every single one of them. And we'll put our graph right here. Okay. So what would happen now if you start to use as an input 2, but you pass it through different types of functions, so different tools that you use to change up this number. So let's try up with the first one, for example. So y equals x squared. So if you use the technique that I used earlier and put in multiple numbers, you'll start to see that a trend forms, and this curve actually looks like this. Oops, where is it? There we go. There. Let's write it out. They're going to be the same color so you can see them properly. So this is going to be our x squared function. And so, but we are inputting the number 2. So let's see what this leads us to. It goes, so x is 2, here on our curve it'll be 4. So you can see also if you put in the 2 right here instead of the x, 2 to the power of 2 is 4. So the point is right here on the curve. So we can also put it as an output. So if we use the same arrows as before, you can see that if you input the number 2 into that function, you'll get 4. Now let's try with the next function. What if you put 2 into y equals negative x? So the function looks like this, and if you put in 2 into the negative x, you'll get negative 2. And you can see it here again. If you put in x equals 2 here, go down, you'll see it crosses when y is equal to negative 2, which is what we found. So there we go. So the input is 2, but our output is different. It's negative 2. So you can see here already that we use the same starting point, so the same starting material or number, which is 2, and by passing it through a different machine or tool like we said earlier, but now is actually a function, you'll actually get a different output. Let's try for a couple more. So let's see, y equals 5 minus x. Let's see where that is. Once again, I did it already off camera to put the functions in, but you can also figure them out by yourself by plugging in random numbers and trying to see what the trend is. So for this one, you can see, let's plug in 2 right here. So 5 minus 2 instead of the x, this is 3. You can also see it on the graph here where 2 is, it's 3 on the curve. So that's perfect. So once again, we got a different output, which is 3. So let's see the final one now. Let's use y equals x plus 1. So if you plug in 2 instead of the x, you'll have 2 plus 1, which is equal to 3. So you can see something interesting here, that you're using 2 as the starting material in each of them, and so far they had been showing us different outputs. However, for this one, we used 2 and it gave us the exact same output as the previous one. So do you remember in the previous example that I used earlier about the paper, remember it is the same thing as using, for example, remember the knife and the scissors as functions or as tools, because both of them actually led us to the same output, the same result, which is the cut up paper. And in mathematics, so your input here, we can also write it out. It was your x every single time. It's the number that you replace with x, like x with. And then your output is the y. So every time you put in an x number, you try to see what the y would be, so what the outcome would be. And there's a term that you can use also in mathematics. You can call the input, you can also replace it by the word domain. Oops, I'll put it on top actually. There, let's just replace it. No, that doesn't work. Let's replace these. So domain would be the input, and the range is your output. So this is the way of saying them, but in more mathematical ways. So now you can see, so in this video overall you can see that I taught you what a function is, so what it really does. So you can see really it is the relationship between the y and the x that now we know under the names of the domain and the range. And so now you can see that for whatever number that you input, your function acts almost like a machine or a tool and changes that number and turns it into the range, which is the y value. And then you can see how it shows up on a function, on the graph. So I hope this video was helpful.